Let us begin with the third session on numerical integration. The objectives of these sessions are that we will be discussing certain numericals which will help us to understand when and where we use trapezoidal rule, Simpson's 1/3 rule and 3/8 rule. Before that, let us revise the formulae for these three rules. Trapezoidal rule has a formula shown here, h by 2 in the bracket y0 plus yn, that is the first and the last term, plus 2 into all the remaining terms. Simpson's 1/3 rule, as the name suggests, will divide the interval by 3, that is h by 3. Then again the first term is y0 plus yn, that is first and the last term, plus 4 into all the odd terms, plus 2 into all the even terms of y. Simpson's 3/8 rule, 3 by 8h in the bracket y0 plus yn plus 3 into all the y1 plus y2 plus y4 plus y5, skipping y3, then skipping y6, y7 plus y8, so on, plus 2 the last term, plus 2 into y3 plus y6. This is the formula which you need to remember when we are using the formula. And as the table shows, we have to remember the trapezoidal rule, we can use it for any number of intervals, and Simpson's 1/3 rule, if we want to use, we must have the even number of intervals, and if the Simpson's 3/8 rule is to be used, then the number of intervals must be a multiple of 3. Let us begin with the first numerical. We need to evaluate the integral 1 upon 1 plus x square in the limit 0 to 1 using trapezoidal rule, taking h equal to 0.2. So the range from 0 to 1 divided by 0.2 will give you the number of intervals, that is, it will come as number of intervals and that's why h by 2 is equal to y0 plus y5 plus 2 into the remaining terms. So there are 5 intervals, and hence we cannot use for Simpson's 1/3 rule, neither Simpson's 3/8 rule. Now putting the finding out the values at the various values of x, that is 0, 0.2, 0.4, 0.6, 0.8 and 1, we get y values, and this we put it back into the equation of the trapezoidal rule, and we get the integration value is 0.78373. Going to the next problem, here instead of giving the equation for fx, the values of x and the corresponding values of fx are given in the table, and here we need to find out the area bounded by the curve and the x equal to 7.47 and x equal to 7.52. So since here the number of intervals are 5, we cannot use Simpson's rules, thus using the trapezoidal rule. Here the value of h is 0.01, that is the difference between the x values. Now writing down the trapezoidal rule for this numerical, the integration of fx within the limit 7.47 to 7.52 is equal to h by 2 y0 plus y5 plus 2 into all the remaining terms. Now putting the values from the given table, we get 0.01 by 2 as the respective values, and the answer will be 0.9965. Now let us go to the example number 3. Here we need to evaluate the integral of log to the base e of x within the limits 4 to 5.2 using trapezoidal rule and Simpson's rules. But in order to use all the three rules, we need to divide the range from 4 to 5.2 into such number of intervals which are even number as well as divisible 3. So that will be 6. So total range from 4 to 5.2 has to be divided into 6 equal intervals. So let us see the value of h. H is nothing but the range upon total number of intervals, that is 5.2 to 4 by 6, that is 1.2 by 6 is equal to 0.2. So the value of h is 0.2. Let us evaluate the values of log to the base e of x at the various interval points. When we do that, we get these values. The first value being 4. When we put 4 into the log to the base e of 4, we get 1.386294. Same way, next value is 4 plus h value, that is 4.2. Likewise, till 5.2 we evaluate. Now let us write down the trapezoidal rule for this numerical. That will be h by 2 y0 plus y6, that is the first and the last term, plus 2 into all the remaining terms. So we get this. When we insert the values from the table, we get the value of integral by trapezoidal rule is 1.82784,724. Now let us write the Simpson rule for this numerical. It is h by 3 y0 plus y6 plus 4 into all the even terms plus 2 into all the 4 into all the odd terms plus 2 into all the odd even terms. Now putting the values from the table, we get 0.2 by 3 and that is the 1.82777264. Okay, now let's write the Simpson's 1/3 3/8 rule for this numerical. It is h by 2 y0 plus y6 plus 3 into y1 plus y2, skipping y3, then y4 plus y5 and plus 2 into y3. Inserting the values, you get the value is 1.82784,705. Let us go to the fourth problem, where we need to find out the integration of sin x dx. The limits are 0 to pi, and here we are told to use trapezoidal rule and Simpson's rule by dividing the range into 10 equal intervals. Now out of Simpson's rules, only Simpson's 1/3 rule can be used here, as the number of intervals into which the range 0 to pi is divided is 10, that is even, and it's not divisible by 3, so Simpson's 3/8 rule cannot be used. So let us know the value of h here. This is range by 10, that is pi by 10. Let us evaluate the values of sin x at the various interval points. When we do that, we get these values. First value being 0, that is the first initial value of x. At that value y is 0. Then next is pi by 10, at which y value is 0.3090. Please remember to keep your calculator on radian mode while evaluating these values. Next, third value is 2 pi by 10. Likewise, we go till pi. And writing the trapezoidal rule for this numerical, we get h by 2 y0 plus y10 plus 2 into all the remaining terms. Inserting the values from the table, we get 1.9843. Writing the Simpson's 1/3 rule for this numerical, we get h by 3 y0 plus y10, 4 into all the odd terms of y plus 2 into all the even terms of y. Putting the values from the table, we get this, and the value is 2.00091. Go to the last problem here. As we had seen in the applications of numerical integration, that a water resource engineer may be interested to know the cross-sectional area of a river bank. This is a problem related to that application. Here a river is 80 meters wide. The depth d in meters at a distance x meters from one of the bank is given by the following table. X is 0, the depth of the river bed is 0. At x equal to 10 from one of the banks, it is depth is 4 meters. Likewise, it goes till 80 meters. So we need to find out the cross-sectional area of the river using Simpson's rule. Now, what are the number of intervals here? There are 8 intervals, so it's the even number, and we'll have to use Simpson's 1/3 rule to evaluate the area here. We cannot use the Simpson's 3/8 rule, since the number of intervals given here are not the multiple of 3. So h here is 10. Area of the cross section is 0 to 80 fxjs. This is the integration we need to find out. Simpson's 1/3 rule is area equal to h by 3 y0 plus y8 plus 4 into y1 plus y3 plus y5 plus y7 plus 2 into all the even terms. So putting the values from the given table, 10 by 3, 0 plus 3, 4 plus 4 plus 9, 15 plus 8, so we get 10 by 3, 3 plus 1, 144 plus 6, that is 710 square meters. So this session gives you a fair idea about the varieties of the numerical integration problems, and we have learned where to use trapezoidal rule and where to use Simpson's 1/3 rule and 3/8 rule. In the next session, we'll be looking at the rhombus method, which is used to improve upon the accuracy of the results obtained by the trapezoidal rule. And there also we'll see the concept of accuracy or error in case of various methods. Thank you very much.